Hey everybody, I'm back. You might think, man, Mr. Patterson's dirty. He wears the same clothes all the time. I'm doing all these videos, trying to pump them out. So I'm just staying up in my room, hopefully trying to get a lot of stuff done. So I am taking showers, everybody. Or every day, don't worry, you guys. All right, so we're gonna jump into 8.6. Now this day is gonna be a little bit more confusing for you. You have solved log equations, but you never had to use the properties when you did them. So again, look back at your 8.5 notes. Watch the videos again, but you have solved log equations, but you never had to condense first. And that's why we said yesterday condensing was going to be so important. So there are two scenarios that you learned back in 8.5. You had a log on one side, not the other, and then you would move the base convert. That's one way to solve a log equation. The other way to solve a log equation, that if you have a log on the left and a log on the right, you simply drop the logs and set the arguments equal to each other. It's going to be the same scenarios today, but we have to condense first. So when I look at number 8, it's actually scenario number 1. When you look at your guided notes, scenario number 1, there is at least one piece that is not a logarithm. Well, 0 is a regular number, it's not a logarithm. So I'm going to have to use that scenario. Well, I look at it and I can use the product property. So make sure you guys really understand your properties from yesterday. If there's a plus sign, you can condense to a single logarithm as long as you multiply the arguments. Well, x times 4, I'm going to reorder it to 4x, and that equals 0. Now, once you condense, it's actually an 8.5 problem. It's going to be where you have a log on one side, not the other. Move the base convert to an exponent problem. So now I have 4x is equal to 7 with a power of 0. Remember, the base of a logarithm becomes the base of the exponent problem. Well, anything raised to the power of 0 is 1. So I have 4x is equal to 1, and when I divide by 4, I get 1/4. Now when you read my notes, you'll see that I put the word valid by it. Please remember, we always have to check those restrictions. The base has to become a positive number, but it can't be 1, and the argument has to become a positive number. You're allowed to get negative answers and everything like that as long as you plug in. Well, when I take 1/4 and I plug it into that argument, that is a positive value, so it is a valid solution. Number 10, you realize that this is scenario number 2 because all the pieces are logarithms. This is a logarithm, this is a logarithm, logarithm, and logarithm. So there's 4 pieces of math up there, and they're all logarithms. So this is going to be where you can drop the logs later. I see too many kids right now just go, oh, everything's got a log base 10, so see you later, see you later, see you later, see you later. That's not the rule. The rule is you have to have a single logarithm on each side. So I'll look at this and I'll realize, well, it's actually 2 product properties. We have a plus sign there, we have a plus sign there. So on the left side, I can condense them to a single logarithm as long as I multiply their arguments. Now, we saw the other day that we probably should distribute whenever we have a monomial times a binomial. So 3 times quantity x minus 6 becomes 3x minus 18. Now in my notes, I showed it separate. I went a little slower, but hopefully you can compare these to the notes and follow along. On the right side, it becomes a single logarithm, and 4 times 6 is 24. Now I forgot log base 10, sorry. So now you look at that, and that's scenario number 2, because everything had a log, and I can do what I did in 8.5. When your log base 10 matches up with your log base 10 from 8.5, you have a single logarithm, you can drop your logs and set your arguments equal to each other. So when I take 3x minus 18 is equal to 24, I will add 18 on both sides, giving me 3x equals 42. Divide both sides by 3, and I get 14. Now remember, just because your answer is positive does not mean it's valid. You have to plug it back in. So when I take 14, the only place that I can plug it into is this argument. 14 take away 6. I really don't care that it's 8. I care that it's a positive number. So it is valid, and I'm good to go. Now, You guys have 6 examples that you're going to copy down today or follow through. I'm only going to explain one more, which again, if you can do this one, I believe you can do any of them as long as you follow the steps. So one of the more confusing problems for kids would be when things aren't kind of like in areas they should be or on the sides of the equation. So we're going to see number 11. It's log base 4 of x plus 2 minus 2, and that equals log base 4 of x minus 4. So now that we got our equation written, what we're going to do is we're going to see that there's actually a non-logged piece or a regular piece, and that makes it scenario number 1. So in my brain, I look at that -2 and I say, hey, you're not a log piece. So what we want to do is we want to basically kind of get sides. We want to make a log side and a number side. Now, in all reality, you could make it whichever way you want. But what I'm going to do is I'm going to tell you what you should always do. The regular number should be positive. It just makes our life easier because you'll see what the regular number is going to become. So you guys, I want to take that -2 and not keep him negative. I want him to become positive. Well, we can move pieces across the equal sign using plus or minus, add or subtract. So I'm going to add 2 to the right side. Now when I do that, I will have positive 2 over there. In my guided notes, I showed plus 2. Now how does this logarithm get to the left side? Because we want a log side and a number side. Well, in order to move a positive piece across the equal sign, we would use subtract. So I'm actually going to minus this logarithm to the left side. And he's going to stay put. So I keep the log base 4 of x plus 2. But I have to minus this logarithm to the left side. And I realize I cannot use a rule yet. The reason why I can't use a rule is I don't have a single logarithm. We always need to condense to get single logs before we do anything. So I look at this and I realize it is the quotient property. If there's a minus sign between 2 logs, you can write a single logarithm as long as you know what to do with their arguments, and that would equal 2. Well, when there's a minus, you're supposed to divide those arguments. And now, hopefully it looks like 8.5. Once you get down to a point where there's a single log on the left side and a single log on the right side, you can drop them just like you did in 8.5. But this would be the scenario where I have a little melody for it. And I go, when I got a log on one side, not the other, move the base convert, right? So we go, when you got a log on one side, not the other, move the base convert. Now, why did I want that regular number to be positive? Because when I move the base and I convert to an exponent problem, he's going to be my exponent. If he was negative, it just makes my life harder. I mean, I still can solve it, but again, I would always like for my regular piece, my regular number to be positive. It's just easier. So now the log goes away. I have the fraction x plus 2 over x minus 4 is equal to 4 squared is 16. Now it becomes an Algebra 1 problem. You would get rid of the denominator by multiplication. So I have x plus 2. When I multiply by x minus 4, they cancel. And when I multiply by x minus 4, I'm going to distribute and get 16x take away 64. So again, the work there was multiply by x minus 4, cross them off, multiply by x minus 4, and distribute. You guys, I'll do a little double switch here. I'll minus x on both sides, leaving me 15x. I'll add 64 on both sides, making 66. And when I divide by 15, I normally don't show that step, but that is not a nice answer. You can use a decimal, okay? Remember the SAT uses decimals. I prefer fractions though. This fraction reduces, they're both divisible by 3, and I get 22 over 5 is equal to x. Now, 22 divided by 5 is x. You could have got 4.4. So 4.4 is a valid solution as well. And if you, that might be easier for you to plug back in. But 4.4 plus 2 is a positive number, so that's good. And 4.4 take away 4, it just stayed positive, but it's a positive number. So it is a valid solution. All right, I hope these 3 examples help you out. But again, it's going to take practice, practice, practice. And the big deal is have your property sheet right next to you. Make sure you're supposed to be doing the power property, the product property, or the quotient property. Okay, this can be pretty challenging stuff, but I think with, again, practice, rewatching the videos. It is important to rewatch these videos. It'll make more sense after you see it a couple of times, and then you guys will get better at it. So stay positive, stay up to speed with everything, and leave me a comment if you want. But I will be posting, obviously, some extra examples and things like that as well, too. It's your boy, Mr. P. Have a great day. Miss seeing you guys here.